Hello, everyone. Okay, so the section that we finished right before the end of spring break was in partial fractions. And in that section, we learned how to integrate the following things. All right, so we learned how to do simple problems where there were linear factors in the denominator. We also did this problem where we had to solve for A, B, and C. Then we went to repeated roots in the denominator. And so the last thing we have to cover in this section are irreducible factors. So let's look at this problem. And what do I mean by an irreducible factor? Well, for an irreducible factor, you can see that I have x squared plus 4. So this is a quadratic. However, it is not factorable. If it was x squared minus 4, then I could write x minus 2, x plus 2. I'd have linear factors, but I don't. It is x squared plus 4. So the first thing I'm going to do is take x squared minus x plus 2 divided by x minus 3 times x squared plus 4. And from before, we know that this is a over x minus 3. So that one is easy. But this irreducible factor, this x squared plus 4, I have to put a linear factor bx plus c over top of it. And now I have to solve for a, b, and c. Oh, let me pause to write something in the chat. All right, so now we know we're solving for A, B, and C. All right, so we need to find our major equation multiplied by our least common denominator. So that gives us x squared minus x plus 2 is equal to a times x squared plus 4 plus bx plus c times x minus 3. Okay, any questions about that? So that is our major equation. And we use that to solve for A, B, and C. Okay, so now when we look here, we can see that our roots of the denominator, well, the only root we have of the denominator is x is equal to 3. So that means since we're solving for 3 things and we only have one root, that means we're going to have to come up with two other numbers in order to be able to get those values. So let's start off. So let's x equal 3. And then I'm going to get 9 squared. I'm sorry, my brain's already squared it and I'm squaring it again. 3 squared, which is 9, minus 3 plus 2. And that's going to be a times 3 squared, which is 9 plus 4. And then when I put in here, I'm going to get bx plus c. But that's times 0, so that's gone. Okay. So therefore, on this side, I'm going to get 8 is equal to, this is going to give me 13a. A is going to equal 8 over 13. So we have our first variable. Okay, so we have 2 more.
You have no idea why this room is so small. At worst, hour, this little room is going to fill up very quickly. That's why the maintenance department
So the problem is now that we have one variable. We still have to find the other two, but we ran out of roots. So we're going to choose some values. So let's choose, I think definitely let's choose x equal to 0, because that always is easy. And so when we do that, we get 0 minus 0 plus 2 is equal to a times 4 plus, and then I'm going to get bx, well, the b times 0 is going to be gone, so I'm going to get c, and then I'm going to get -3. So now I get -3c is equal to 2 minus 4a. Okay. So I get -3c is 2 minus 4. A is 8/13. So the denominator I'm going to use is 13. So I'm going to get -3c is going to give me 26 minus, well, that's 32/13. This is -6/13. So therefore, when I divide by -3, I get c is equal to 2/13. So now I have my second variable. So again, I can choose anything I want. I've already used 0. I'll choose something else small. So I'm going to choose x equals 1. And when I do that, I get from the major equation 1 minus 1 plus 2. So I'm going to get 2 is equal to a, and it's times x squared plus 4. So that's going to be times 5 plus bx. Bx is just b times 1 plus c, and then that is times 1 minus 3, which is -2. Okay, so now if I just throw some algebra and do some work on this equation, I get -2c is equal to 2 minus 5a plus, oh, I'm sorry, I'm trying to solve for b. -2b is equal to 2a minus 2 minus 5a, and then I'm going to get plus 2c on that side. So I get -2b is equal to 2 minus 5a is going to be 40/13 plus 4/13. Common denominator is going to be 13 again. So I'm going to get -2b is going to equal 26 minus 40 plus 4/13. And that looks like -10/13. So when I divide by -2, I get b is equal to +5/13. And I have solved for all of my variables. Okay. So I had this. And so I know that A is 8/13. And I am going to separate really? Okay, hold on a minute. It's still it's not acting nice right now. Yep. I gotta stop share for a sec. It's still not back. Yes, it is. Okay. And then B is 5/13. And C is 2/13. So I'm going to break that up and write this as x squared minus x plus 2 over x minus 3 times x squared plus 4. And that's going to look like 8/13 times 1 over x minus 3 plus 5/13x divided by x squared plus 4, and then plus 2/13 times 1 over x squared plus 4. Okay. So now what I need to do is plow through and integrate. Okay. So my original problem now becomes the integral. Let's pull out the 1/13. And then we're going to get the integral of 8 times 1 over x minus 3. Well, actually, we can integrate it. We don't need to go through all that. Well, let's just integrate it. So we're still going to get an 8, but we're going to get a natural log of the absolute value of x minus 3. Then I pulled out the 1/13, so I'm going to get a 5. And this is x over x squared plus 4. So that's going to give me 5/2, the natural log of x squared plus 4. And then I'm going to get 2. And now this, what is this going to give me? Anybody remember? What's that going to give me? When I integrate, what am I going to get from that?
Is it the natural log?
Okay, we got the natural log from this one. This one gave me the natural log because its derivative is on the top. This one over here is a special integral. Okay, it's going to be 1 over a, which is 2, the tan inverse of x over a, and then I'm done, plus a constant. So that is the last part of partial fractions, which is what to do if you have a irreducible factor. Okay,
Dr. Lott, two
yes,
questions. The first one is that integral sign supposed to still be there? Like the one after the 113?
nope.
Okay. Secondly, how did we factor out the 113?
Each one of them had a 1/13.
Okay, I get it.
So that's why I pulled it all the way to the front. And thank you for helping me to remove my integral. Originally, I was going to rewrite the problem. Okay, any other questions? Okay, so just for kicks, I want you to give me the partial fraction decomposition. Of x squared, x minus 4, x squared plus 6, x squared plus 8. So what's the partial fraction decomposition of that? What do I have to get? So I want you to work on that and then give me an idea. Then somebody can please volunteer and tell me what you get. Any takers? Nobody? I definitely had somebody in the other class. Okay. So this is going to be A over X plus B over X squared because it's a multiple root plus C over X minus 4, it's a single linear factor, plus DX plus E over X squared plus 6, and then FX plus G over X squared plus 8. So you have 1, 2, 3, 4, 5, 6, 7 variables to solve for. And you only have 2 roots.
Excuse me, Dr. Lott.
Yes.
Why is A over X rather than putting it over like X squared? Why are you starting with A over X?
Whenever you have a repeated root, you have to carry it all the way up to the power of that repeated root. So like in this one, which one was it back here? This one. So x cubed minus 2x plus 1 over x times x minus 1 cubed. That's a repeated root. So that's a over x. That only appears to the power of 1. But I'm going to have b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed. So even though this power is 3, I have to carry it out to the third power.
Okay, I understand.
Alrighty.
So what? So why? If you scroll up, you have after C, you add e d of dx plus e and fx plus g.
Okay, so that was what we just did. So that's the irreducible factor. So we have x squared plus 6 and x squared plus 8. They are irreducible.
Okay, I
Okay.
understand.
Yeah, so these two right here are irreducible.
Thank you.
So they have to be done the way I did this last problem where I put the cx, bx plus c. Prentice, are you okay with that?
Yes.
Okay. All righty.